up everything that. Scott would start talking to me because he wants to strange stuff. So he'd start talking about it. I just don't understand. I want to do zero to it. I don't want to like it's hard for me to it's very hard. My college is it's almost like
喂，拿两个就行。
那我先拿，因为我接上后面。
All right. Good morning for day 2 final. All right. So we have 5 teams today. Against crowd. So we have 5 teams today. The final presentation gives a sense of what they accomplished this semester. They have 15 minutes and 5 minutes. Keep an eye on the time as well.
Good morning, everyone. Welcome to the final presentation for Icebreakers. We are a team of 6 with Jonathan Walton as our instructor and Mike Crystal as our faculty consultant. Our project involves creating a VR pickleball game that uses Oculus Quest, allowing 2 players to play against each other. Our goal is to recreate the physics of pickleball in VR and present the game in a competitive and entertaining format. To recap what we presented on halves, we finished our first playable demo where 2 players can join the same room and play for rallies with reasonable ball physics. And we also tested the viability of the teleportation system for player movement. And the feedback we got from halves included scope concerns regarding the doubles mode, as well as doubts about the teleportation system's potential for closing disorientation and motion sickness. So through the playtest day, we realized that the necessity of having a good tutorial to onboard our players with all the rules and game features outweigh the need for allowing 4 players to play together. So we cut the doubles mode and used the time left to polish what we had and refine our users' experience. So for the second half of the semester, we spent a lot of time figuring out how we could distinguish our game from the VR tennis game. And along this way, what we did is to always think back to the uniqueness of the sport itself, which includes its rules, accessibility, and social interactions. And finally, a very important principle that we followed is to make this game easy to start but hard to master. So we want there to be enough space for beginners to learn and grow, as well as providing advanced techniques and strategies for pro players to explore.
Before we dip into the game modes and system design, let's see a preview of our core experience. By combining different techniques and features, players can engage in pickleball that simulates the real sport, compete with tactics and strategies gameplay. After we show a little bit about how this game works, let's step back to game modes. So we designed 3 game modes with different purposes. The first one is the single mode. It is our core experience. The second is the training mode, including practice and tutorial. The training modes help players to know how to play pickleball rules and how to improve their pickleball skills. To enhance the player experience, firstly, we create a matching system to ensure that 2 players could join in one specific room by filling the same room number. if two players enter the same room number or they enter a wrong room number, we will have an arrow page for this situation. It will, after a player creates a new room, it will allow to choose from 3 different boards, 4 different characters, 2 different pedals, and 2 different balls. During play singles mode, we designed a voice chat to help players socialize and talk to each other. They can share their feelings immediately or even do trash talks. Also, we have voice announcements to help players to know, for example, nice serve to help them to know they get the point, or need to serve diagonally to explain why they lose the point. To help players who have never played pickleball before, we create a tutorial including 2 parts. The first part teaches players how to play the game itself, including using the controller to move and grab the ball. These are all the basic rules that players need to know before they come into the singles mode. And the second part introduced the rules of pickleball, such as how to score and where to serve. We wanted to help players understand how pickleball works and making it like they are playing a real game in a real court. This is how tutorial works in VR. We implement all pickleball rules in our games to create a realistic experience. And after players are familiar with pickleball, we have a training mode for them to practice and improve their pickleball skills. We design specific training modes for different purposes. For example, serving or hitting. In this picture, we show that the player is trying to hit the ball to serve to a specific position. So all these system design were made to create a comfortable and enjoyable experience for players, helping them prepare and have fun in the game modes, in the singles game modes.
Okay, so let's talk about our gameplay. As you can see, we have a teleport and joystick control to be our player movement system. And we will teleport the player to a position that is close to the ball. And then they can use a joystick to do some minor control. So for the teleport, we have 2 modes, the regular and net. So for the net mode, we will teleport the player to the landing position of the ball and an offside. So this offside means we will give a space behind the ball, which means we will give a space that is comfortable for players to return the ball. And as you can see in this picture, so each player was properly teleported to the correct position. And for the net mode, this mode was designed for a more aggressive playing style. And the teleport position will be determined by the kitchen line and also the flying trajectory of the ball. So as you can see, after I switched to the net mode, I was teleported to the kitchen line, and I used a volley to finish the game. Okay, spin. So we have the 3 different spins in our game: flat, top spin, and back spin. So by using the spin, players can make some troubles to their opponent. At the same time, how to distinguish the different spins is also very important in our game. So for the flat spin, as you can see, we use a wide trajectory to show this normal shot. But for the top spin, the situation is different. So we use the right trajectory to show the top spin. Actually, after the first bounce, the ball will become a little bit faster, which means the players need to move a little bit forward or backward to change their position and return the ball. And that's why joystick matters. So about the backspin, so we use the blue to show the backspin. And the ball will become slower after the first bounce. And players need to move forward and reach the ball. Okay, curve. So based on our original physics system, we add a new force to the ball and made this curve system. So you can see by twisting or raising a certain way, players can make a curve. Technically, this is the most difficult technique in our game. So this also shows our design philosophy. Easy to start, but hard to master. Okay, kill shot. So when I was talking about the teleport system, you may just very curious about, because we're always teleport the player to the correct position. So what if no one makes mistakes? So the game will never end. So our solution here is to build this kill shot. So we will calculating the flying time of the ball and the time it takes for the player to move to the landing position and compare these 2 times. So if the flying time is shorter, we will never teleport anymore. So by taking advantage of this mechanism, we encourage players to play this game in a more strategic and aggressive way. So dink. Dink is very important in pickleball because players really want to return a ball that is close to the net and hard to return back. So we use this special function. We use this special function to build the dink. So as you can see, in this function, compared with the linear function, the ball's velocity will be very slow when the paddle's velocity is small. So which means if you move the paddle very slowly, the velocity of the ball will be very small as well. So the dink will be easy. And so in the feedbacks we got from Hubs, so Chris mentioned that we can add some physical feedbacks on the controller to help player to get a sense of hitting the real pickleball. So then we add some haptics features in the game. So we created a sweet spot on the paddle. So the closer the contact point is to the sweet spot, the stronger the vibration will be. So which means this feature can help players to understand and help themselves to do some self-correction and do some personal improvement in the future.
Okay, let's talk about art. So to enable our players to have a richer gaming experience, plus we need a different cores to differentiate the various features of our game. So we made 3 game cores. So this is the first one, which is not only one of the game cores, but also a court for our players to train and learn tutorials. And this is the second one, and this court is specifically designed for night play. If you want to play pickleball in evening, you can try it. And next is our third court, because we often play pickleball in RPIS. So our third court, which is also RPIS, and we will use it as the lobby of our game. And we also made some Easter eggs in the RPIS, such as the ball we hit on the ceiling partition. If you look at the ceiling now, you can see the balls are still staying there. Yeah, and we also installed large screens in both courts, so players can easily see the game score at any time. And this is our 4 game characters our players can choose from before game start. And for the UI, to help players navigate through our various features in our game, so we create a simple interface that players can access in the lobby and training court. And this is a UI when player in the lobby. Yeah, it looks like that. And this is the UI for the tutorial, and players can watch the tutorial through the big screen in the training court. Yeah, it's like that.
Okay, so let's talk about our challenges during this development process. So at the beginning, so the ball physics is very important. One lesson we learned from this process is that do not use the Unity physics to build your sport game because it's not reliable enough. So we built our own physics engine. So we built our own physics system based on the Unity engine. So we create our new physics system and synchronize every parameters in the game, and then transfer ownership with delay. So about the network, so networking is very annoying during this process because we need to cover a lot of things in the networking environment. So we should cover the scene selection and the movements matching and some voice system based on this networking system. And about our development management, so because we have the networking and the local 2 parts, so the management of the network and the local are very important. At the same time, so when should we decide to stop developing and polish is very important for to ourselves to consider about. So developing and polishing is also another important factors in our development process.
Okay, now I'm going to talk about playtest. These are some photos from playtest day and soft. And these are some data. We have over 50 playtests to experience our game, and we received 35 surveys. This is a picture of about our overall feedback from playtest day, and we are glad to see that most of players enjoyed our games. And move to some detailed feedback. Many players don't like the previous audio announcement like you win, you lose, so we replace it with reason to win or lose, such as ball is out of boundary, etc. And that suggestion said that the previous racket hitbox is not big enough, so we iterate this hitbox to optimize the receiving experience. And we have some more demands from players said players need more time to learn the rules and control of our game. So we iterate tutorials such as add more steps and redesign the UI. And also players said they want to practice their skills, like practice like spin, something like that. So we add a serving part for our training mode. Those changes highly enrich the experience of our project. Now head over to takeaways. The most important lesson we learned in this project is the networking is hard, and a sports game is hard. And networking plus sports game is don't do it. And just kidding. And talking some real takeaways for programming side, I want to highlight again that customize our own physical system is highly recommended for a sports game to meet different needs. And for design, we have to be detail-oriented, which means we need to spend more time on focusing how to design our scope. And for art, we want to give a shout out to our solo artist, Pule, who finished all the artwork perfectly. And for playtest, we think it's pretty hard to get in-depth feedback in just 20-minute sessions for sports game. So we definitely should find more long-term playtester to give more valuable feedback.
Okay, to summarize, we developed a multiplayer VR pickleball game, and we wish to create a competitive and entertaining experience to let players learn and enjoy pickleball. And we're now open to questions.
In your videos, you can see that there's often a time when the ball suddenly moves by itself in the air. What causes that?
Yes, so that has something to do with our solution to solve the ball's ownership transfer in the network. So what we did is to constantly detecting the ball's like to which player the ball is closer to, and transfer the ownership of the ball to the player which is closer to the ball, because we want the experience of the player who hits the ball to be smooth. So he needs to be in charge of the authority of the ball in the network. And when you switch ownership, when the ball is crossing the net, the ownership will be switched because it's closer to the other player. And at that time, the position will be synchronized to you, and the authority of the ball's ownership is the other player, and that's why it's glitching for a second.
Do you think it's possible to solve that problem?
Yes, we actually came up with the idea like after the playtest day, which is maybe only synchronizing the ball's position when your opponent hits the ball. So instead of making it a shared object across the network, making it a local object, but only synchronize the position when hits happen, so that it can be smooth for most of the time. But it needs a rework for the whole networking system, and with all the like gameplay and like audio system function we already put in, it will be just too much work for us to rebuild it. So we did not choose to go to that path.
Thanks.
So you invite a lot of skill and strategy with netball. I'm curious, were you able to play test it with anybody outside of the team? And what did you learn from play testing that new netball feature?
So because we actually finished almost everything last week, so we didn't put a lot of effort to do the external playtest. So, but based on the playtest day session and other playtests before last week, so we think all the skills is, so for most of the players in our game, so they only have 15 or 20 minutes to play our game, and sometimes they need 15 minutes to learn how to do some basic shot and hit the ball back. So they don't have a lot of opportunities to use some advanced techniques. So we didn't get so much feedbacks based on this.
Alrighty. Hello, everyone. We are Team Chatbot AI. This is our team. Our faculty instructors are Dave and Brenda, and our consultant is Heather. We are a student pitch project looking to explore the usage of ChatGPT in video game development by creating a complete interactive narrative experience driven by AI characters. We explore these ideas through the development of our game, Hysteria and Housebend. In our game, you are called to a colonial New England town when their beloved reverend is found dead, and the town suspects witchcraft. Throughout the game, you must talk to the three suspects, Hope, Elizabeth, and Adam, in order to uncover the truth and identify who you think is the witch. Our characters are powered by ChatGPT to give close to real-time responses to your typed questions, pulling from over 750 dialogue examples written by the team. Each character has their own side of the story, so it's up to you to pull the pieces together and uncover the truth when making your decision. Throughout your questioning, different suspects can give information both about themselves and other people, even going so far as to accuse each other, such as Elizabeth here accusing Hope on the basis of being a dangerous woman. You are even able to lie to the suspects in an attempt to get them to give you information. For example, here, Adam will respond to your claim that Elizabeth has accused him, even if Elizabeth never actually said anything of the sort. We designed our characters to be emotionally dynamic throughout the experience, changing their behaviors based on the questions you ask them, how you go about asking them, as well as the growing pressure from the crowd outside. You're free to utilize whatever strategies you feel are necessary, including bringing up topics that are a little more sensitive for certain characters, such as Adam here with his drinking. When it comes to strategy, we also noticed that the characters will actually respond to typed action in addition to questioning. As shown through the example here, when you threaten Adam with a knife, he will respond in tow, even if it's not the most traditional method used in an interrogation game. When you are ready to make your decision, you can accuse any number of the suspects of witchcraft. There are 8 endings in total, each detailing the aftermath of the witch trial and the overall effect that your decisions had on Housebend as a whole.
So the biggest challenge that we've had, how do you turn an established character into a robot, or a robot into an established character? First step, write the character. We want the personalities of the characters to be colorful because ChatGPT doesn't really do subtlety, so you want to communicate the character through their dialogue as powerfully as possible. Step 2, convert what you've written into context that you actually send to ChatGPT in order to generate responses. So we divided our context into 2 different categories: description, which is the general character description and the description of the situation, and dialogue examples, which are examples that ChatGPT can use to then generate its own dialogue based on them. We wanted to simulate character change. To simulate our real conversation, we wanted the character to change emotionally somehow throughout the course of the conversation. So we figured out the simplest way to do that is to pick one variable that can change according to player input, and what better variable to pick in an interrogation game than stress. So once we figured that out, we mapped each emotional state that we wanted the character to go through with stress and how each character would respond differently to it. For example, with Adam, when he's at low stress, he feels disgruntled. When he's at medium stress, he feels enraged. And when he's at high stress, he feels depressed. We wanted the character to have a kind of big change at the end to show that we are revealing a new side of the character to the player and rewarding them for their work in the interrogation. Step 4, map to player questions. We figured out which questions we wanted each character to answer, and we came up with dialogue examples answering each of those questions. And then step 5 is to combine both the emotional and the question responses and generate each question answer based on the emotion that the character is feeling. So one rule to have is to avoid vague context, because ChatGPT will invent its own context and it will contradict what you have written before. So one way to do that is to avoid using only pronouns, because even if we humans can infer who they're talking about, ChatGPT cannot and will probably plug in a different character. Another thing to do is to create example dialogue explaining details in a different set of dialogue. For example, here Adam mentions patience when talking about his kids. You need to explain who Patience is, otherwise Adam will invent something that might contradict what you've written before. What if we want the dialogue to be vague? Especially relevant in an interrogation game where we don't want the character to give away all their secrets. Well, the best solution that we have is to tell it in the character's description. Number 1 rule is you want ChatGPT to know what you are doing, and so you have to be specific.
But all these complex systems for emotional and deep characters don't really matter if the player doesn't know how to interact with them. We found that our format of open-ended conversation is hard. It's role-playing, embodying and acting as another character, and a lot of players struggle to do it. And it's made even harder because it's interrogation, which is a format of conversation most people don't have an experience with. So all these problems kind of compound to this blank page effect, where players have basically no idea what to say, and we need to overcome this fact to get players to engage. If you think about it, conversation is hard even in real life, where I hope you know the character you're playing and the setting you're in, or at least have experience with it, and we don't get the benefit of any of that in the game. So we need to get you in character as fast as possible. And this is especially prevalent because we found the most common moment for this blank page effect is the very beginning. So they never engage with the loop, and they will have a real struggle engaging with the game at all. And we had 3 methods for overcoming this. The first was limit your information just enough to start. We focused down on giving players a goal, the stakes of the situation, establishing the characters, and giving the immediate scene of the death, because we're in an interrogation crime game, so you need that. The next thing is to prompt the player. The best way to negate the blank page effect is to not give the player a blank page. Have the character talk to them first. They establish the tone and the topics, and the player can build off of that. And 3 was to give example questions. So if the player is well and truly stuck, they have things they can default back to and ask. Things like asking about the other suspects, or where they were when the Reverend died, or who they think is the witch. The other thing is to overcome players' unfamiliarity with interrogation. We give them a guide on how to interrogate. We give them the overall goal of pushing characters to their emotional breaking point to force them to reveal information. We give them information that they're looking for, like discord in relationships, or the misdeeds and crimes that people think have occurred, or the sins they're trying to hide from you. And we give them strategies to elicit the emotional reactions to get this information, like using various tones, or pressing on topics they don't want to talk about, or looking for contradictions between the characters, or forcing them to reveal information about the others by turning them against each other. But once again, none of these systems matter if the player can't tell when they're working. So one of our core lessons was feedback is everything. For example, here you can see that the player is accusing Adam of being a witch in a stern tone, which sets him off. This gives a reaction in his portrait showing how angry he is, as well as a textual response to reinforce that the portrait. And then Adam has a response that shows this angry state, calling your accusation ridiculous and deflecting blame to one of the other suspects, Elizabeth. This reinforces that the strategy was effective and encourages the player to keep doing it.
So here's a deeper dive into how we actually use ChatGPT to generate our responses and run our game. So when the player types in a question, we send a message to ChatGPT, which has several different components. It has a general description of the setting and the character. It has example dialogue specific to that character, and of course it has the actual player question. So in this case, the player is asking about Adam's children, and since children is another stressful topic for Adam, one of the examples has him basically giving no useful information on the topic. So based on that example, the actual response ChatGPT gives also gives no particularly useful information. So this was originally all we were sending to ChatGPT to generate the responses. However, we discovered that often when the player is asking similar questions, the responses are inconsistent or downright contradictory, and that's because ChatGPT doesn't actually remember the previous responses it gave. It treats every request as completely separate. So to solve that problem, we started storing the chat history. We started storing the chat history, the question and the response, and sending that in each request that we sent ChatGPT. So since Adam is actually does not like talking about his children, when he was asked about this, his stress level changed from low to medium. And the way we simulate this in our game is by switching to a completely different set of examples and also different character description. And so here we can see that in the medium stress state, Adam actually gives much more useful information about his children, including their names and ages. And so in this case, since the player didn't get an adequate response the first time he asked the question, he is asking about Adam's children again. So you would expect that Adam would actually give a useful response this time based on the new medium stress context. However, he doesn't, because what happens here is that since we have both the previous chat history and the dialogue examples, and in this case they essentially contradict each other, the previous chat history overrides the examples we're giving. And so the way we decided to solve this was to actually rewrite the chat history by essentially sending all the questions we had answered before. We had generated answers for before, but this time with a new medium stress context as opposed to whatever context was being used before. And so here, finally, the chatbot actually responds with a useful answer, giving the children's names and their ages.
So looking back, the past 14 weeks has been an amazing journey for our team, and being able to experiment with this new technology and try to use it in video game development is a great learning experience. It is also a pretty winding road because nobody has done this before. We don't have a lot of game or existing work to reference and had to explore our own path. And the fact that ChatGPT is a black box just adds to that challenge. There's no easy way to learn or comprehend what is exactly happening behind that technology. So what we presented so far mostly came from us constantly throwing input at ChatGPT, try to observe and summarize a pattern, and then incorporate it into our design. And one interesting story we can share is that halfway through the semester, we accidentally found that ChatGPT responds to action really well, It's something that we haven't accounted for at the start of the semester, but we just decided to embrace it and incorporate it into our experience, and it ended up being a happy surprise to reward player who tries to do something differently. And it's just one example of all the surprising discoveries we made throughout the semester. And the tech is also evolving all the time. On the exact same day as our HAPS presentation, GPT 3.5 Turbo came out, which is, according to this title, 10 times cheaper with better results. And we were always up for the challenge, and we decided in this case to make the pivot through spring break and implement a new system that allows us to switch to the latest GPT version. Although there were challenges, we received a huge amount of support and inspiration when we talked to all the experts in the industry about our project at GDC and other venues throughout the semester. We spoke to developers at companies at Ubisoft, Square Enix, and Shell Games, and it was exciting to know that these companies are also actively developing or planning to develop projects with ChatGPT technology. We're able to pick their brains, ask questions, and also exchange information by sharing our own experience working on this project, which feels really rewarding and validating. And the validation doesn't just come from conversations. We started to collect playtest logs early in the semester along with some parameters automatically with the custom tool. And over the course of the past 14 weeks, we collect over 80 playtest sessions and have witnessed over 20 sessions where players spend over 30 minutes to interact with our chatbots, which highlights the level of engagement our game was able to create for our players. And having so much learning so far, we have decided to write an article to share all our findings and some details that we might not have time to get to today. The target audience for this article will be game developers who are interested in developing a game with ChatGPT. We're currently writing our first draft, and we're looking to publish it later this month. Of course, we're also releasing the game. History Houseman is currently available on itch.io and will soon be available on Steam. After publishing the game, we'll start to submit our game to multiple conferences and festivals to share our work to a wider audience. With that being said, we are proud of what we came up with. We're grateful of all the supports we got along the way, and we hope you enjoy our presentation, and we're now open for questions.
Yeah, did you consider doing a live demo for the presentation, and what deterred you away from that?
We did consider doing a live demo. We were already very pressed for time because we had a lot we wanted to talk about, and we thought it was mostly a time issue, less than a confidence in the game issue, but we did consider it quite a bit.
I was going to ask for some of the surprises, so I'm glad you shared a surprise about the Rock and Hope in this. I'm curious, how often, when looking at the logs, do you think the chatbot strayed from your list of 750 responses and kind of introduced something new or unexpected? Was this a frequent occurrence? How much do you think you need to see? Another way of asking this is, how important were your 750 seed dialogues to get this all going?
So I think every single playtest that we had, in one way or another, improvised some detail of the story. Our 750 were based on setting the core events, especially around the actual incident itself, as well as to set the scene for who the characters were so that the chatbot could improvise from there. Knowing that we were working with AI, we did not come into it with the expectation that they were only going to be using the examples we gave, so it's actually sort of a welcome improvisation on behalf of the game. But yeah, the goal was to get it so that they were improvising the small things and not improvising the large things, but there was improvisation in most every playtest.
And yeah, most of it was improvisation we expected, on the less important details. I would say about once or twice for every playtest, it would improvise a important detail, and that's something we have to deal with, but like 90% of the time it stuck to that 750 and gave the facts and story we wanted to.
I was just going to ask you, after doing this, what do you feel like is the next steps for this technology? Is it in this space now where you feel like limiting it to a constrained premise in a sort of indie game form is where it should be? Or do you feel like there are opportunities to take this to a larger scale for a much more involved game experience?
So the way our format works is like very modular. You need these little modules. In our case, we did stress and emotion. You could expand that to far more complex characters that have a much larger number of modules and a much more complex way of adding and switching them, events in the world, interactions between multiple characters, all these kinds of things. So you could certainly make it deeper. You could also make it wider. A big team, this is a very dividable workload. You need to write these modules. You could divide them up between a bunch of team members. So you could easily do a far larger array of NPCs. So as far as conversation-based AI, I think you could expand in both directions and do very different experiences, AAA level to really deep 1 to 2 character indie experiences.
I will say, because of the amount of examples that you have to write, if you have a huge team of writers, you need to communicate. Because you have the AI improvising and contradicting itself. You can't have people contradicting themselves too.
And I think one additional obstacle is that there is no way currently to run this technology locally. We have introduced ways to use an API call for our game, but it's the charging comes based on the number of calls a player is able to make in one session, which is there's no way to predict that. So our current publishing strategy is that we release the game and give players the option to enter their own API keys so they will take care of their own charges. But on a larger scale project, it's definitely something that needs to be solved.
All right,
Thank you.
Thank you.
Good morning, everyone, and today we're going to be reading an interactive story called We Are... Uh-oh. It looks like we're missing our title. I need you guys to help us out, all right? Everybody raise a hand, point a finger up, point it towards the board, and draw an oval just like what we have around We Are, just like this. Awesome, thank you guys so much. You did a great job. We are Team Story Studio. My name is Lori. With me are Damien, Felicia, Lauren, Randy, and Yan Yan. Our instructor is Ruth, and our clients are Anne and Debbie from the Children's Museum of Pittsburgh. Now, Team Story Studio developed an interactive storytelling toolkit, which includes prototypes and guides, storytelling guides, that the museum can use to facilitate interactive storytelling events. These events are expected to host between 50 and 100 people and will be hosted in the museum lab space at the Children's Museum. Now, originally, the Children's Museum asked us to take existing children's stories written by authors and turn them into these kind of interactive events. So using that original book, but making it something that kind of keeps that same story while making it more engaging. And our team had to come up with what this kind of in-between section was. Our solution was to develop a storytelling toolkit, which, as I mentioned before, includes storytelling guides, how to turn existing stories into interactive stories, a digital prototype which is similar to a PowerPoint-like tool where you can turn it into a book, physical prototypes, demo stories, and an audio library. And now I'll pass it to Lauren to talk about our stakeholders.
Thank you, Lori. So when we were designing our project, we had to take into account 3 different stakeholders. The first is the content creator. The content creator is a high schooler in a workshop or a museum employee who will take an existing storybook and convert it into interactive storytelling content using our toolkit. Next, we have the storyteller. The storyteller is a museum employee that takes that interactive storytelling content and uses it to put on an event at Museum Lab for 50 to 100 people at a time. Finally, we have the audience member. The audience member is a visitor to Museum Lab, particularly families with children ages 3 and above. Now let's take a look at what an interactive storytelling event might actually look like in the end. So this was a demo created by our team based on the existing storybook called This Is Owl. And in this video, you're going to see some unique interactions which are simply not possible with traditional storytelling techniques. The first one that you're going to see is the yelling interaction.
Okay. 1, 2, 3.
Inserting physical props into a digital scene. Interacting with Arduino sensors. Animations. And moving physical character props. Now let's pass it to Randy to hear about our toolkit.
Thank you, Lauren. So for our interactive storytelling toolkit, we have 4 parts inside. The first part is our storytelling guides and tutorial. The second part is our digital tool prototype. The third part is the physical interactive prototype. And the fourth part is our story and the playtest results. So now let me use our content creation pipeline to help you go through the whole process. First, the Children's Museum need to find an author who is willing to partner with them and turn their work into an interactive storytelling event. Then the content creator need to plan out the whole event according to our storytelling and interest curve tutorial. And these are meant to be read by anyone aged high school and up, and instruct them to design an engaging interactive storytelling event. Then you need to prepare all the digital assets. If the original art asset is provided by the author or the publisher, you can straight go to our tool, or we also create tutorials for how to snip out the things from the scanned book pages. Now you have things ready and you can move to our tool. In our tool, we have different kinds of outputs like preset animation, custom animation, built-in sound library, and physical servo motion. And every output is attached to an input in our tool, which can be either a click or the physical Arduino interaction. All the Arduino interaction is pre-built into our tool, which means the content creator don't need to write any code or go through the Arduino IDE, as long as they stick to our presets. Now, the content creation is done. You can export all the things and bring that to your home, and the event can start. Now, let me pass it to Damien.
Thanks, Randy. Since not everybody is a really professional narrative designer or storyteller, our problem is to teach them how to create their own story and design their own direct interaction. We prepare guides for them. So these guides contain 3 parts. Each part contains over 10 pages information to teach all the users how to create their own interaction and host their storytelling interactive event. First part is about the story bits. We use Pixar in the Box as a source to teach them how to create their own storyboard firstly. The second thing you need to know is the interest curve. You will find the right point at your interaction here. The last part is you have to implement your interaction and host your own storytelling event. The next part is our digital tool. I will hand to Yan Yan to talk about it.
Thank you, Damien. So this is a small demo of our tool. We can implement assets into a library, drag them into the edit window, and do the editing like rotating, resizing, flip over, or change the layer of the assets in the edit window. We can also change the background and add on different text materials. We can also add new pages and do the same editing on those pages as well. And then we can add interactive events to the assets in the editing window. These interactive events can be triggered by a mouse click, Arduino sensor, and lead to animation, sound effect, and Arduino servo. We have an event list on each page for the user, which contains all the details of those interactive events on that page, so they can see and edit on those events anytime they want. And after all that implementation, you can preview the story you made in our tool. You can see that since we have already added an arcade button as our input, so the playtester can use the arcade button to turn pages and play the animations and all the other things. We have also implemented a sound effect library for the content creator. Since the original story already contains many text and image materials, so these sound effects can help the content creator to build more vivid interactive stories. These sound effects are sourced from Steve's ETC sound library. We have also prepared different kinds of tutorials for the user, so you can learn how to use the tool based on their own preferences. Now I'll hand the mic to Felicia.
Thank you, Yan Yan. As we discussed in halves, we went through several UI iterations and playtests to make sure our tool is intuitive for users with different computer experience. One of the examples is that our playtester tend to add multiple assets onto the same board. However, the background may not stay fixed all the time. This increased the difficulties in editing. As the result, we separate the image import function out of the library. We separate the background import function out of the library. This means that the content creators can select and set the backgrounds, and it will stay still while they're editing. With this kind of feedback and considerations, we designed our final user interface, which is focusing on higher consistency through a design system. Unfortunately, in the last week of the semester, we realized that we have a problem with the save and load functionalities. In order to make sure that our tool will be most useful for the museum despite all the problem and the time constraint, we decided to go into deliver two versions of our tool. The first version of our digital prototype tool will include all the planned features, but without the save and load functionality. This means that this version could be used to illustrate the potential of the tool going forward and serve as the base for UI design. And the second version, which is a reverted set of our current digital prototype tool, however, it has the save and load functionality. This means that the content creators can set up events in the workshop or in the office and transfer the digital files to assembly hall for storytellers to present it. In a short conclusion, we're going to deliver a base version of our digital prototype tool and a framework for future development. Now I hand the microphone to Lauren.
Thank you, Felicia. So now I will talk about our physical interactive prototypes. So we had a big design challenge with this project where we're trying to design an event that can host 50 to 100 people at the same time. So when you have this many people at one event, how do you make sure that each individual guest still feels engaged and still feels like they can directly contribute to the event? So the way that we tried to tackle this design challenge was with these Arduino sensor kits. By placing Arduino sensor kits around the room, we're creating a more individualized experience for each guest, and we're allowing them to have more of a direct impact on the storytelling event than they could if it was just a projection screen across the room. So we have 3 different Arduino sensor kits ready to choose from, including the arcade button, the servo, and the RFID. Each one comes with its own robust wood custom laser cut housing, and these housings even include locks for the housings which are directly guest facing. So one of the great things about these Arduino sensor kits is that the museum employees don't need to have any technical experience in order to implement them. All of the technical background is already taken care of by our team. We've already custom laser cut all of the housing. We've already done all of the wiring, all of the programming. It's already all set. They just plug, play. It's immediately ready to go. And another great thing about these Arduino sensor kits is that they can act on their own, or they can interface directly with our digital tool. Now I'll pass it to Damien to talk about the next element of our toolkit.
Thanks, Lauren. So the last part is the demo story and the playtest result. First thing I would like to show is our event concept art. You can see this event contain the physical interactives and the digital content. You can see a huge projection on the wall, and there are so many physical interaction that all the children, they can play with it. So for our playtest, the left part is we host a playtest in the Highland Elementary School for the first graders. Every children, they feel active all the times and really like to be involved in the storytelling event. The right part is the playtest day. We host the event for the families, and everybody try to do the interaction all the time, and the result is pretty satisfying for us. About the challenges, we do some tech tests in the assembly hall in the museum lab. This is the place we will host our event. And we test all the equipment we're gonna use, and the microphone, the speakers, HDMI, and the huge projector there. But we face some problem like they have really bright light. It cannot see the screen clearly. And then our event will host over 50 children there. They will have really noisy echoes all the time. We need to figure out those problems. And the last part, we'll let Lori talk about it.
Thanks, Damien. Now, in reflecting on our semester, our team feels that we did some things pretty well. In particular, we spent 6 weeks at the beginning of the semester exploring and narrowing the blue sky prompt given to us by the museum, which was essentially to explore how to facilitate a storytelling event. Next, our team conducted several playtests, which served us really well in designing parts of our tool and our event. We conducted playtests for the event side with over 30 first graders, with kids ages from 6 to 16, as well as families. We also conducted playtests for the tools side of things with junior high students, high school students, and adults. Finally, we feel that we did a pretty good job in developing these guides and tutorials, and actually took people through those tutorials to ensure that they would be beneficial to the museum. However, our team also made some mistakes this semester. And in particular, we focused really heavily on exploration over the functionality of our tool, which means that now at the end of the semester, we have to deliver those two versions of the digital tool to the museum instead of the original one that we had promised to them. Next, we could have done better in communicating during iterations, especially in the second half of the semester. When we were going through all those different UI iterations, sometimes parts were changed but not well communicated to the whole team, which resulted in confusion and inefficiency later. And finally, our content creation timeline remained ambiguous to us throughout most of the semester, and we realized in hindsight that we should have spent more time prototyping what it feels like to be a content creator and what that time looks like. This does result in a few lessons for our team. First of all, defining the terms of our project more clearly, particularly prototype and beta level. Our team had a different understanding of a prototype and beta level tool from our instructor and from our client, and that resulted in this problem the last couple weeks. Additionally, we need to be better about managing expectations in terms of overpromising to our client what our digital tool will be able to do, and having stricter internal deadlines so that we can catch problems like that save and load pipeline much earlier in the semester, instead of pushing for feature developments all the way till the end. Our team would like to give a special thanks to all of these wonderful people, and a super special thanks to Anthony and Shirley, our faculty consultant. In summary, we are Team Story Studio, and we are now open for questions.
What do you think is going to happen next with this work?
So we are very hopeful that the museum is able to use everything that we've created in terms of the pieces of the toolkit aside from the digital tool. And then this work is actually going to be going to the museum, and then Anthony will be kind of acting as our liaison and take over what our project is. So in addition to everything that we've mentioned here, we're writing up an extensive report on how you would go about using the tool, all of the known problems with the tool and things like that. That package will all go to Anthony and the Children's Museum, and then hopefully the digital tool can be developed further from there. In the meantime, a program like PowerPoint or iMovie can be used to fill that gap. And well, even though it won't have the functionality of linking with the Arduinos like we wanted it to have, that can be used, and those interactions can be faked, which is something that we are putting in that report.
Thanks.
Get a clarification. So you're saying that I didn't see how you could say they could use it if you can't save it, but you're saying that they can use it by faking it through a PowerPoint?
So there's a lot to unpack there. We are delivering two versions of the tool. One of them cannot be saved. That was the slide where we had the comparison. The other one can save, it just doesn't have as many features. And so that version of the tool can be used for these events. However, if you want the full functionality of the tool until it's able to be fixed, essentially, you can use PowerPoint as a stand-in, like what we did for some of our playtests, and then use kind of the faked interactions where if you hit the button, somebody clicks. And that still has that same, I caused something to happen, even though electronically it doesn't trigger it.
Hi everyone, welcome to our final presentation. We're Danceology. So this is our team. I'm the producer Xiaoying, and Angela, Yiming, and Jason are our programmers. Christine is our 3D artist and animator, and Xiaoying is our UI designer. Our instructors are Shirley and Ricardo. And now I'll give it to Jason to introduce you to our project.
Thank you. All right. I'll first talk about our client. Our client is a Paul Taylor dance company sitting in the center of New York City. It was created by the famous choreographer Paul Taylor in 1954. And after Paul Taylor passed away in 2018, the company continues to preserve his legacy through educational programs, performances, and archival work. Oops. I didn't press anything. All right. Next, I'll talk about our client requirements. Our client mainly requested us to create an application that would basically explore the intersection between art and machine learning. They would also like this application to increase the awareness of the complexity of modern dances, as well as highlight Paul Taylor's legacy. And the back exercise is a 30-second long exercise created by Paul Taylor himself. The client chose this exercise because it shows the fundamental philosophy of Paul Taylor Dance Company, which lies within the use of back and spine. And this is the only official exercise Paul Taylor created to address on this concept. So for our target audience, we're mainly targeting patrons of the dance company, people who are interested in Paul Taylor's legacy, and people who are open to personally experience the dance experience on their own. Here's our deliverable. We develop a guided single-player interactive application that teaches users the back exercise. It helps people develop understanding of the art form by giving the opportunity for them to learn and perform the back exercise on their own. And our application is able to show the invisible energy and forces visually from the spine and critical movements in the back exercise to better convey the core components of the exercise, and actualizing the imagery of the dancer's mind to aid the understanding of the piece. Next, I will pass to Christine.
Thank you, Jason. So in this section, I'll be talking about the structure of our experience, which will be divided into 4 stages. In these stages, we'll include an introduction and 3 levels that are about different learning steps. From now on, we'll watch the video demo on each section, and I'll explain throughout the video.
They're downloaded. They're downloaded.
Yeah, as we're focusing on the back exercise, we're going to start with the back exercise video provided from Paul Taylor Dance Company. Alongside the video, the voice recording will be played, talking about the origin of back exercise and the key components of the back exercise.
Reaching out into space.
Moving on to the next stage, which will be level 1, is our basic tutorial. It's a basic tutorial to help the players to understand the movements. And we will first calibrate the camera that will be used throughout the movement, throughout the experience. And now, the player will watch the whole back exercise.
Paul Taylor's back exercise. Unlike most exercises, it isn't fast or aerobic. What you've just watched was a demo of the first half of the back exercise.
Now, the player will watch the teacher's movement
Begin
on the
standing
screen
upright
with the
the feet
voiceover
together,
guidance.
Facing forward, arms at your side. Bend your knees while curving your back and your arms. Lift your arms.
We'll also have the visual aids to provide the better understanding of forces and energy.
Bring your arms
The
down as you bend your
voice
knees.
recording will be
Curve your
played
back
until
and
the
slide your
first
right
half
leg
of the
to the left.
exercise,
Turn
and
inward
after
so
that,
your right
the
knee is pointing
player
at
will
your left
follow the flipped
Your right
version
heel
of
should come off the
exercise,
floor. At the
and
same
there will
time,
be no
twist your
voiceover
shoulders to
guidance.
the left and bring your right elbow across until it is pointing down.
Next stages, levels 2 and 3, will have a more accelerated learning experience. The player will try the back exercise from the start to end without any voiceover guidance. But as you can see here, there will be hints will be provided in the forms of icons demonstrating next poses. And also, there will be feedbacks given on each poses in both sound and text. Now I'll hand it to Yiming to talk about our iteration and final deliverable.
Thank Christine. So in our midterm, we finish our core experience mechanism, including AI-generated animation and motion capture based on webcam. We also finish a dance level based on the back exercise and a simple, straightforward UI systems. After that, we did our first iteration in which we finished detailed tutorial levels and change our main things of our environment. After these playtest days, we did our second iteration in which we adding a lot of 3D art assets and change the whole UI system, iterate more details. To conclude our final deliverable, our artists made an immersive 3D environment and the main character. We also modified our matching algorithm to give player more precise feedbacks. After that, we did a lot of playtests and iterate our tutorial level to enhance the effectiveness of this tutorial. Last but not least, we also improve our UI systems to give you a more clarity of the experience. Next, I will hand to Xiaoying to talk about visual and sound.
Thanks, Yiming. So for visuals, our character is modeled after Aaron, a dancer from the Paul Taylor Dance Company, and we built a relaxing environment with vivid color to align with the character style. And for the sound, we used a calming music, and some playtesters mentioned there's a yoga feeling. For UI iterations, initially we had a dark color scheme, and later after we finalizing all the 3D models and the environment, we changed our color scheme to light blue and white to reflect our uplifting and relaxing experience. And we also provided more feedback and guidance for our camera calibration process, so the users are in the perfect position to start our experience. Next, Xiaoying will talk about the playtest.
So playtesting is a really important part of our project. And other than attending all of the required playtests by the ETC, we also regularly attended the playtests on main campus in the Hunt Library. So in total, we playtested around 7 sessions and with around 43 naive users. So there's a lot of feedback that we received and iterated based on the feedback. The first thing that we looked at is interrupted flow. So initially when we designed the tutorial level, we divided it into several chunks. So the user would watch each chunk first, follow, and then watch the next one. And they would hold at the end for each position. However, after playtesting, we realized that this really breaks the flow of the dance. So in the end, we iterated and created an uninterrupted tutorial level with voice guidance. The second thing is unclear guidance. So initially, we asked the users to go into the learning immediately. And what we learned through playtests is that this creates a lot of confusion. People don't really know what they're getting into. Therefore, we created an introduction in the beginning, showing the back exercise from beginning to end first. And the next thing that we discovered, which is a very important thing we realized this semester, is that there's a really big learning barrier when people trying to learn movements mirrored. So to help people learn, we created a lot of visual aids for that. So in the beginning, we created a UI screen that would tell you which side is right and which side is left. And we also created a color-coded ankle and wristband to help you understand which side you're turning towards. So now I'll give it to Angela to talk about technology.
Thank you, Xiaoying. So our project used a lot of technology. We worked with machine learning for our project. So I'll go over our process, some of the challenges we encountered, along with the final pipeline that we established by the end of the project. So the first thing that we have is that before halves, we did have a working animation pipeline where we were able to take video from a recorded video from Paul Taylor and turn that into a 3D animation. However, there were issues where the ML model would output very noisy data, right? There'd be sudden jumps and jitters with the motion. So our naive solution for halves was just to apply a filter to this motion to iron out all of the little kinks. But unfortunately, this caused the intensity of the dancer's movements to be severely muted once we translate that over to a 3D animation. So you can see here that on the left, we have the dancer fully extending their arms. However, once that's been translated to the 3D model with this clean data, it lowers the intensity of it due to just doing filtering. So in order to combat this problem, we turned to modern day literature on how they combat this kind of issue, and we settled on this algorithm that would filter out noise based on the acceleration, and specifically if it found unnatural spikes in acceleration, it would get rid of those points. And it would also maintain the peaks and the lows of each of the movement curves and interpolate in between. So that way we would have both the smooth motion and also a reduced noise from before. So here you can see on the left side with the red model, slightly jittery motion with a lot of random noise. And on the right side here, we have the much more clean curve after applying this algorithm. So at this point, we have our pipeline where we first take the video, insert it into our Python program, clean it out, and then put it over to Unity to make animation, right? So that's super great and all, except we had a couple of issues with that final animation. So unfortunately, our ML model outputs only position points, and turning that into rig-based animation means we had to do some kind of interpolation between the point itself and also the rotation of each of the joints, which is what like a 3D animator would do. Unfortunately, doing this mathematically would end up with very inaccurate values, and you can see here that it caused many deformations in the model itself, along with the model's limitations on how it estimated the z-axis caused a lot of the depth-based information to be lost. So unfortunately, after just doing this pipeline, we would end up with an animation that was less than satisfactory because of all of these deformations and sudden jumps in motion. So we attempted many different solutions throughout the course of the semester, but ran into all of these different roadblocks. Eventually, we had to settle on tuning the animation manually, which was less than ideal, but given the time constraints, what we had to settle for. So given our current pipeline, we had to then additionally add a pipeline where we move the animation over to Maya, manually tweak these keyframes, and then put it back into Unity to apply the animation. And you can see that our final result is much smoother than what we saw before.
So we learned a lot of really important lessons this semester, especially like what Angela mentioned before with the machine learning model. First, be aware of its limitation. It doesn't read depth very well, so maybe a 2D animation instead of a 3D animation would be more suited. Second, it doesn't read the spine information, so an exercise like the back exercise that focuses on the spine is difficult to do. And also be aware of the training data and what you're giving to the machine learning model. So the initial machine learning model is trained based on regular people doing more simple dances, but what we're giving to it is a dance that's done by professional modern dancers. Therefore, it created an animation that's not what we desired. And also, like I mentioned before, that we also spend a lot of time tweaking the design for the teaching, especially that we realize people have problem learning things mirrored. Therefore, we spend a lot of energy in figuring that out. However, we haven't solved that completely, so it's just something to be aware of. We also created a lot of documentation in terms of tech and a user guide for the client to develop the project further or use it immediately. So in summary, Danceology is an interactive single-user application that explores the intersection of art and technology and also increases the awareness of the complexity of modern dance by teaching the Paul Taylor back exercise. Thank you for listening. We're now open for questions.
I'm not sure I completely understand what the machine learning part of the project was. Can you explain that a little bit?
Yeah, for sure. So what we used was machine learning to do pose estimation. So rather than doing like a full-on motion capture where they would have to, apply a lot of other things to record this exercise, we simply took a webcam video of what they had and ran a model through that to convert what they danced over to that. And we also use it for live feedback. So when a user is using our experience and dancing along, it's able to detect your movements using that same model and compare that to the reference video and provide you with feedback.
So given that, why didn't we use motion capture to capture the initial movements of the actual dancers doing this?
Definitely. So initially, it was because of the technology constraints. Our clients didn't have access to that type of technology, so we were trying to simplify the pipeline. In the end, it ended up causing more work for us. So in hindsight, we were trying too hard to shove the design to fit the technology than we should have. Yeah.
Yeah. However, we also feel like it's a very exciting thing to explore if we can, input a video and output a good 3D animation. That's something we're looking towards in the future.
So it feels like your team faced a lot of technical challenges and kept kind of trying to push through them and push through them and push through them. And in the end, you still have some of them that you're still kind of struggling with. If you were to give advice to another group that was attempting something like this from the beginning, what would you tell them?
So I believe throughout development, we were aware that there would be a lot of technical issues, and we tried to come up with fallbacks, but I think not following through with that enough. So having way more fallbacks would have been nice. I think we committed to using like 3D animation very early on, and that was something we didn't want to let go, and it ended up biting us in the back by the end. Yeah. Thank you.
All four are good. Just sometimes students mute them and other students don't know how to unmute them.
All right, good morning, everyone. We're Revita Animation, and welcome to our final presentation. This is our team. We have Ryan, Jason, I'm Jackie, Dennis, Shen, and Yuxi. Our faculty instructors are John and Ruth. A quick product overview. We're trying to deliver a 3-minute animation video based on a pre-production package given to us. We're trying to raise the awareness of plastic pollution, and our target demographic is PG-13. This is the pre-production package given to us. It contains a synopsis, a story, and a short version of storyboard and animatic. And this is the pipeline that we follow. To summarize this, our artists use various different softwares to create assets, and we put everything into Unreal Engine for the final render. We'll start with some halves feedbacks. So faculties were concerned about our progress. They were concerned how we would deliver our story clearly. We didn't have a lot of finished scene shots and just being overly ambitious overall. And here's what we did. We stayed on our original track in storytelling, meaning that we're still telling the story in reverse chronological order. We believe that this kind of reverse narration adds more excitement to the story. And for the second part, we created a fully rendered animatic, replacing all the 2D placeholders, and we iterated after that. And for the last part, we ranked our priorities and made some necessary adjustments according to that. For example, we prioritized our plants and character animation, and we lowered the priorities of certain effects that would take a lot of time to do, but would appear very shortly in the film, such as fluid sim and fracture effects. And these are the audience feedback that we get. These mainly came from the playtest day guests, faculties, soft opening, and alumni soft openings. Most of our guests understood the story well. They think that the flashbacks were well presented. We also receive a lot of artistic feedbacks that we take careful consideration into our final 2 weeks of production. And now let's take a look at our final animation.
Witnessed a strange, aggressive reaction in the latest strain.
The consumption rate is at 27%, but the growth rate is exceeding expectations and...
Listen to me! We've got until the end of the month to deliver what we promised. Understood?
Understood.
You're the boss. Huh. Well, that's odd.
Billionaire Gregory Mason Oldenmeyer has announced that his company, Waste Not, is poised to bring about a game-changing approach in how humanity handles the waste of single-use plastics. He says that they will soon be unveiling a revolutionary new biotechnology to develop microbial enzyme crops capable of breaking down common forms of plastic like PET and HDPE with much more efficiency than traditional methods and without releasing any harmful toxins. Oldenmeyer insists that through careful cultivation and precise gene splicing, Waste Not is set to eradicate plastic pollution from the globe and transform the world around us.
Thank you. In the past 6 weeks, we have finished the final production of our animation. We constantly made iteration and improvements based on our every week's updates. Also, we overcame many challenges and solved many technical issues, both in animation and lighting rendering, while using Unreal to work with Maya and Blender. This is where we are in half, and now we finished all the outside environment of the lab. And we also add all the animation to Unreal, and we assign them to Unreal's MetaHuman. So every week, we iterate our assets, animation, lights, as well as sound effects. And we also did the final polishment and add post-processing in the last 2 weeks. We finished the final editing yesterday and remapped all the soundtrack to it. Next, we'll talk more about details.
Thank you, Dennis. We've been through a lot, and let's see what our working process is. So let's first talk about the cinematics, and we'll be divided into 2 parts. First is the lighting. We've been adding extra lighting to help us light up the characters and also the environments to better tell the story, as you can see. And the other one is the connection. So we have been connecting all the beginning and the ending of each shot so that the audience will know where they're at in the story and also where they're at in the environment. And let's see what the asset creation is. We've been making our self-made smart materials to help us boost the productivity. As you can see, we just need to drag the smart material onto the blank model, and it will generate all the details for us. And what we need to do later is to tweak the other details to make it more believable. And these are some showcases of using these smart materials in our working process, which really helps a lot. Another technique is using the tiling materials, and it is amazing to using only one picture that can tile around the whole surfaces, which save us a lot of time when creating these large-scale 3D objects. And another thing that's important for us is to referencing to real-life materials. As you can see, this is referencing to a polyfoam. And this is how it looks inside the environment, which looks exactly the same as polyfoam. And another technique we are using is using special effects. So we are using these world bubbles and these fake fogs to create a sense of making of water inside these cabins, which really makes it more believable. And the most important thing inside our project is decomposition. So we've been running through different iterations of making these compositions, as you can see from the half. And the most important thing for our projects is the contrast. We need to have contrast in both colors, lightings, and also the contrast in time. And as you can see on the screen, these are very huge contrasts between the previous time and the current time. And we're going to take one picture as an example to see how we make these compositions. And we've been applying the rules of thirds, leading lines, and all these visual rules inside our composition to lead audience eyes. And for example, on this picture, we are leading your eyes into the center cabin, which is at the thirds. And this is the focus of this picture. And we've been applying these rules within the whole piece so that we can have the right focus in each frame. And also we have contrast in intensity and color as well. And the most important thing, the contrast between different time. As you can see, the atmosphere and the color are totally contrasting. So we have the contrast in the time, which is the post-apocalyptic and the promising, the human-made and the natural. And next, we'll talk about the foliage system.
We spend a lot of time on deciding, doing research of what kind of plants should appear in the current time environment. And then we used this kind of speed tree algorithms to generate the trees. It seems simple, but behind these algorithms, there's dozens of parameters to control the trees. We have to adjust them and balance these parameters well to make the trees feel natural. Then there are 2 hero trees. The hero trees are in customized shapes, so we used ZBrush to sculpt them by hand. These 2 hero trees will wrap around the human characters' bodies. One of the challenges we're facing is that how could we highlight the characters' bodies in such a chaotic planned environment? We used some lighting techniques to do that, except for the key light and the field light. We used the simulation of sunlight spots by square lights to put them to where we want the audience to be noticed, like the acts and the face of the characters. Then is the animation of the plants. We created an algorithm by Blender geometry nodes. There are also lots of parameters to adjust to make them feel natural. Then we'll talk about the challenges.
Yes. So I want to briefly summarize the challenge we faced when working on this project. This animation has an unusual storytelling style, and it certainly brought us things we need to handle properly. The first challenge is obviously how to let the audience get the point that the story is in reverse chronological order. And we use the growth in plants and the progression in background sounds to provide hints. And next, in communicating the jump in time to the audience, we purposely added visual motifs that stayed in both current and past time scenes with different looks to provide guidance. And in addition, we made a huge visual contrast between the two timelines so that the audience won't get too confused about jumping between different times. And in addition to that, we also encountered a lot of unforeseen technical issues when trying to put things together, including lost changes and conflicts between versions. We had to always prepare for extra time for handling these issues, and we also separate the rendering task to make sure small parts of the animation were correct first before putting them into the full piece. And finally, the hardest challenge for us was simply brought by the scope of the project. And our instructor's suggestion was to have a strict workflow that everybody follows and make as many iterations of the animatics as possible. But to be honest, we were not able to follow this workflow until the very last few weeks of the semester. So we didn't quite overcome this challenge. We will be discussing this more in the lessons we've learned.
So I will be going over kind of the lessons we learned, especially about the animation pipeline that we realized the importance of a little late in the semester. So first is the use of ShotGrid and our 3D animatic. ShotGrid was really helpful for getting really quick feedback from John and Ruth and with task management, and our 3D animatic was really good for proving our pipeline, letting us see all of our work combined together, and also letting us know which shots needed more focus and care on. If we really took advantage of these two tools, then we would have definitely gotten into a very quick, iterative, rapid working cycle that would have really benefit our animation. Other than that, we also realized the importance of team production over individual work. So for a lot of the semester, we got too focused on producing high-quality content individually and separately rather than coming together as a team for a full final product. As we started using the 3D animatic more, we really focused on getting out an animation as a team. So overall, having only 13 weeks to produce a 3-minute animation and also learn the tools that we used, the animation pipeline, creating the processes for really developing and combining our work, as well as developing the visuals of our animation, was a huge challenge for us. And over here, we have just a list of things that we would really want to work on if we had more time, such as really developing all of our animations more, having more background music with 2 contrast motifs, and really developing the lab and the plant overgrown environment. So that is everything. Thank you so much for watching and listening. We are Vita Animation, and we are open for questions.
So essentially, you guys have a horror story. What would you say was really challenging about telling a horror story? It's really difficult. So, how did you guys pull it off?
The hardest point for telling the story backwards is because we reveal everything. So we have the ending at the very beginning. So people might consider that it might be the climax. So we need to try to control the interest curve of the audiences so that they won't lose interest at the very beginning since they know the ending at the very beginning. So we are revealing it using the flashbacks, which are little peaks inside these interest curve. So we can even though they are concaves, but still people will get interested when they see the flashbacks. And when they see that moment, they will see, aha, that's the reason why it happens like that. So we are constantly triggering people's interest
during this whole long process, still people will keep interested, even though the animation is working till the end.
Along with that, really to like push the horror, I think a big part is to really establish that feeling of fear in the characters. Obviously, we would love to have like more time to really push those facial expressions, and as well as the like liveliness of the plants really like attacking these people. That's another thing, yeah.
What did you have to change from the original bid package?
I think, except from the characters, we change everything. Yeah, so the environments, we design the environments ourselves. So based on the packages, so it's like it's an abandoned laboratory. And based on the elements, for example, these transparent cabins, we took some of these elements, but we designed the environment by ourselves. But we still keep the same as how the character design concept part is originally given. And our artists still have their freedom, like to control how these elements on the body that can show their identities. So they still have the freedom, but the characters like kind of goes within that constraint.
And in terms of this storyboard, we also ended up leaving out a lot of shots just because of our large scope and our time constraints. And we also switched around some of the camera movements that they gave us. Yeah.
So watching the film, I was surprised by my emotional reaction to it. Was actually pretty strong, which I think is credit to your team. One thing I was noticing though is that in some places it seemed like the most effective shots are ones that had relatively like little movement, right? Where like you had the people kind of pinned down by the plants and there was sort of like writhing but not a lot of complex animation. Was that something you did intentionally in terms of trying to make those shots effective?
So what we did is combine like the vines with the human bodies, and it's hard to make these two exactly same pitch in Unreal. So we made motion, like human skeleton motion in Maya, and we did the curve binding with the skeleton, using the curve to generate the vines version motion, so it's hard to like make them exactly match together. So we just use the small motion instead of using like very extracted motion. Yeah.
All right, thanks, team.
Thank you.
Okay, congratulations to the team.